Hi everyone, welcome to today's video on linear, homogeneous, partial differential equations with constant coefficients and their solution. First of all, we shall see what is a partial differential equation, particularly homogeneous type, and its solution. So first of all, we shall see how does a linear homogeneous partial differential equation looks like. An equation of the form a naught into dou power n z by dou x power n plus a1 into dou power n z by dou x power n minus 1 into dou y plus a2 into dou power n z by dou x power n minus 2 into dou y square plus so on so forth plus an into dou power n z by dou y power n equal to capital F of x comma y. Here some constants are there. What are they? A naught, a1, a2 and so on so forth an. And on RHS side, a function is there. It is denoted by capital F of x comma y. Here what are the quantities this f of x comma y contains? It contains some functions of x and y. Now coming to the main topic, why this linear partial differential equation is called as a homogeneous one? Because here all the terms contains derivatives of the same order. See the first term, dou power n z by dou x power n. What is its order? Its order is n. See the second term, dou power n z by dou x power n minus 1 into dou y. Its order is also n. See the third term, dou power n z by dou x power n minus 2 into dou y square. Its order is also n. So, some nice notations are provided. Instead of writing the whole massive equation or this big equation, we can write it in very simple terms. Whenever dou power r by dou x power r appears to you, you just put capital D power r, and whenever dou power r by dou y power r appears to you, write d dash to the power r. See, for any sort of equation, there will be some shortcuts. That means we can write it in a very short form. So the above equation can be written as a naught into capital D power n plus a1 into d power n minus 1 into d dash plus a2 into d power n minus 2 into d dash square plus so on so forth plus an into d dash n whole of z is equal to capital F of x comma y. Or more precisely, it can be written as small f of d comma d dash z is equal to f of x comma y. So it is the standard form of a homogeneous linear partial differential equation. So coming to the solution of this homogeneous linear differential equation, see, in the case of ordinary linear equations with constant coefficients, what is the general solution there? The general solution consists of two parts. One is the CF and one is the PI. CF means what? The complementary function, and PI means particular integral. In the same way, here also, whenever the problem is given in the form of f of d comma d dash into z is equal to 0, we need to find only the complementary function. Whenever the problem is given in the form of f of d comma d dash whole of z is equal to capital F of x comma y, we need to find both the complementary function and also the particular integral. Next, here in this video, in particular, I am going to deal with the problems on complementary functions only, and I am discussing those cases. So in complementary function, two cases arise. So one is when the roots are real and distinct. When the roots are real and distinct, so in what type we have to write the solution? Z is equal to f1 of y plus m1x plus f2 of y plus m2x. And whenever the roots are real and equal, what you have to write? Z is equal to f1 of y plus m1x plus additionally you have to attach a x before f2, and you should write like this: x into f2 of y plus m1x. Now I am choosing a problem. It goes in this way. Solve 2 into dou square z by dou x square plus 5 into dou square z by dou x dou y plus 2 into dou square z by dou y square is equal to 0. So first of all, what we have to do, we have to write the given equation in the operator form. So what is the operator form? The first step, in place of dou square z by dou x square, you write capital D square. In place of dou square z by dou x dou y, there are two terms. One is dou z by dou x and the other one is dou z by dou y. So in place of dou z by dou x, you write capital D. In place of dou z by dou y, you write D dash. And the third part, that is 2 into dou square z by dou y square. So we have already learned, no, in place of dou z by dou y, or whenever dou z by dou y comes to you, just write D dash. Since it is dou square z by dou y square, you have to write D dash square. So the equation goes in this way: 2d square plus 5d dash y plus 2d dash square whole of z is equal to 0. After writing in such a format, whenever d is there, just put m, and whenever d dash is there, just put 1. So by substituting these things, what do we have here? 2m square plus 5m plus 2 is equal to 0. So this is in the form of a quadratic equation, and we very well know how to factorize the equation. 5m can be written as 4m plus m. So 2m square plus 4m plus m plus 2 is equal to 0. Take the factors. So 2m into m plus 2 plus 1 into m plus 2, it goes on like this. So what are we left with finally? M is equal to minus 2 and m is equal to minus half. So how are the roots here? Here the roots are real and distinct. So what is the format? Here we have to write z is equal to f1 of y plus m1x plus f2 of y plus m2x. So in place of m1, you substitute minus 2, and in place of m2, you substitute minus half x. So what is the final equation? f1 of y plus 2x plus f2 of y plus y minus half x. And next I am taking another example. It goes in this way: d square minus 4d d dash plus 4d dash square whole of z equal to 0. So already it is written in the operator form. So straight away we can write the auxiliary equation. So what is the auxiliary equation? M square minus 4m plus 4 is equal to 0. We need to factorize it. M square minus 2m plus 4 is equal to 0. So what are the roots we obtained? M is equal to 2 comma 2. See, here the roots are real and also equal. So what is the structure we have to write here? Z is equal to f1 of y plus m1x plus x into f2 of y plus m1x. What is m1 here? It is nothing but 2. So z is equal to f1 of y plus 2x plus x into f2 of y plus 2x. So now we shall have a quick recap of these things what so far we have discussed. We have discussed what is a homogeneous linear PDE with constant coefficients, and what are the two parts of this particular equation, complementary function and a particular integral. And in this video I discussed only the complementary function and how to find the complementary function. First of all, we have to write the given equation in the operator form. Next, we have to find the auxiliary equation. If the roots are real and equal, just we have to write z is equal to f1 of y plus m1x plus f2 of y plus m2x. If the roots are real and equal, z is equal to f1 of y plus m1x plus x into f2 of y plus m2x. If my video is really helpful to you in clarifying the topic, drop a like and subscribe Subscribe for more math content. And before signing off, students, let me know in the comment section if you want more problems on this topic. Thank you, students.